Mr. Benson here again with the follow-up video on area. So here I'm going to look at composite shapes in a bit more detail. Again, we've got the learning intentions in terms of the knowledge and skills and the exercises to complete on this video as well. So what do we mean by composite shapes? So composite shapes are formed when we combine multiple simple shapes into a larger, more complex one. And the reason we want to think about this is that, as we've seen in the previous video and our previous learning, calculating the area of a rectangle or a triangle is quite easy. And so if we can separate the composite shape into its smaller, simpler shapes, then all we need to do is do some calculations for those. And like you can see with this example here, we've got a square, a triangle, that's embarrassing, trapezium, and a Pac-Man style circle with a sector chopped out of that. So when we're forming composite shapes, what we've got to remember is that they can be formed by adding shapes together, subtracting shapes from each other, or a combination of the two. So we might start off with a square. Now obviously the area of a square is really easy to calculate, but then we might subtract a circular shape from that. And so the area of the blue that's remaining would just be the area of the square minus the area of the circle. So that's the subtraction. Then we might add something else on. So we might put a trapezium on the side of that. And so our blue area would now be the area of the square minus the area of the circle plus the area of the trapezium. So let's look at an example to actually find a composite shape. So here we've got, well, I don't know really what this thing it needs to be. It doesn't need to be anything in particular, but the main thing is that we need to think about the shapes that are present in our composite shape and think about other information there that's going to help us. So one thing that we've got here is, well, we've got a right angle sign, that's nice. So, and we've also got information here that these side lengths are the same from these little symbols here. So what it means is that this must also be 50 millimeters. And so I've got a square in the middle here, which is nice. Now, it also means that this top side must be 50 millimeters. Now, if you get given something in a maths problem and it looks like half a circle, it's meant to be half a circle, unless they really tell you otherwise. So what that means is that the diameter of this half circle at the top would be 50, which means that if I was to draw a line to indicate the radius here, that would therefore be 25 millimeters. Behave. Right, so what have we got? So the area then is going to be the area of the square plus half the area of a circle. And so it's just going to be 50 times 50 plus, so a half pi, and then I've got 25 is my radius squared. And what I get from that is 3, 4, I'm just going to go 81, I'll just round to the nearest millimeter, and it's millimeters squared is my answer there. So that was a pretty simple composite shape. I was just adding a square to half a circle. So here are some examples of other composite shapes, just to show you, what they might look like. This first one on the left-hand side is pretty easy. We've got our donut shape, which is just a large circle minus a small circle. So just always look for those sorts of easy subtractions. But then you might get something a bit more interesting over here, like this yin-yang sort of shape, that might be a little bit harder for us to figure out what's going on. Now, if I manage to, sorry, I'm just trying to draw a line down here. Oop, not my best work. Okay, managed to draw a line down the middle there. And what you can see is that we've actually got a few shapes that are relatively easy to figure out now. So we actually have a small circle here, and we also have a small circle here, and this circle on the right on the top here, the small circle has been subtracted from a larger circle on the left hand side, and this little circle here has been added onto the shape on the right hand side. Now, one thing you might notice as well is that these two shapes actually have the same area and would cancel each other out. So we could just disregard that and imagine that we're just looking at half a circle on the left hand side there and work out the area of half a circle. So yeah, with these, they are not always easy. Sometimes the shapes are straightforward and kind of jump out at you, but other times you do have to interpret information, think about things you already know about geometry, be careful that you're actually establishing the radius of a circle rather than the diameter. That's a common trick. And yeah, with practice you'll definitely start to figure the more complex ones out. So now have a go at the exercises that we've listed previously, and these will be put up on OneNotes and Compass and stuff like that for you to use as well. Now, when you're doing these, check your answers pretty frequently. So every 3 or 4 things that you've done, go to the back of the chapter and check your answers. Now, then what you should do is start to sort of assess your own progress a bit here. So if you're getting everything right, you want to move on a bit. In fact, you might even skip ahead possibly rather than doing a whole lot of the same kind of question. If you're making mistakes, practice some more. So say, we've suggested that you do A and B. If you got those wrong, then maybe do C and D and E. If you're still having problems, a really good thing to do is to check with your classmates first. If you can assist each other and teach each other a little bit, that'll actually develop your understanding really well. And then, of course, you've got us. So send us an email or something like that and get in touch, and we'll support you with those.